Let's look at graphing factored form of polynomials. We're going to start by reviewing factoring, and then we'll graph from factored form. Let's get ready. You're going to need notes and a pencil. And we're going to start by reviewing factoring. So this original problem is in standard form. A is 1, B is 9, and C is 20. So remember, when we factor, we can make our X puzzle. And my top is what multiplies to A times C, so in this case 20. And what adds to B, 9. So what two numbers multiply to 20 and add to 9? That's a 4 and a 5. Because A is 1, I can put those right in parentheses, and I have Y equals X plus 4, X plus 5. Keep in mind we do have an equation, so I kept the Y equals to keep it as an equation. So it looks like that. And then when I graph it, it looks like this. So notice I have X plus 4 and my x-intercept is negative 4. I have X plus 5 and my x-intercept is negative 5. So just think about that. Keep that in the back of your head. Let's factor another one. So A is still 1. So I want to think about what multiplies to negative 15 and adds to negative 2. Well, it's going to be 5 and 3. And the 5 has to be negative in order to give the negative to the negative 2. A is 1, so I can go right to my factored form. X minus 5, X plus 3. And I graphed it. So again, notice X plus 3 leads me to a negative 3 x-intercept. So if we think about it, when it was in vertex form, inside the parentheses, we said it had to be the opposite. That is still true here. So X minus 5, the opposite is going to be a positive 5. If I take each of those, the X plus 3, and I set it equal to 0, because Y is 0 at the x-axis, then X is going to be negative 3, and that is my x-intercept. X minus 5, set it to 0, X equals 5, and that's my x-intercept. So factors help us find our x-intercepts. The factor, which is X plus 3, that's my factor, and then X negative 3, 0, is my x-intercept. Knowing the factor can help me figure out my x-intercept. They have opposite signs. Let's try to factor this. I notice it's in standard form. I also notice I don't have a middle term for a B value, so B is 0. But I do see that they're each perfect squares. X squared is the perfect square of X, 16 is the perfect square of 4, and it has a minus sign in the middle. So this is an example of a difference of two squares, and I can use my pattern to factor this. So it becomes Y equals X plus 4 and X minus 4. Remember, you have different signs there. So when we graph this, we have this picture. This X minus 4 tells me that X is going to equal 4, so that's my positive x-intercept. And then this one is X equals negative 4, so that's my negative x-intercept. If we look at the equation, this equation happens to be in standard form, and we know from standard form that this last number, which is my constant, is my x-intercept. Sorry, my y-intercept. So this is going by 2's, 2, 4, 6, 8, 10, 12, 14, negative 16. I can see that my y-intercept is down at negative 16. This is also vertex form, because I could do X minus 0, which really doesn't change anything, minus 16, and I can use my transformations. It does not move left or right at all, but it does move down 16. And then because it's symmetrical, that's why I have a positive 4 and a negative 4. Let's factor this one. This is a perfect square trinomial. I know that because my first term is a perfect square. My last term is a perfect square of 3. And when I double that, I get 6 in the middle. So if I use my sign of B, this is going to factor to X plus 3, whole thing squared. Let's see what happens when we graph this. Well, remember that when we have this thing squared, that means two sets of parentheses, X plus 3 and X plus 3. So that means I'm going to get a negative 3 and a negative 3 when I set them each equal to 0. So this graph comes down hits the -3, and then it bounces back up. We have a special word for that, and that's called tangent. We would say the graph is tangent at -3. You can also say it has a multiplicity of 2. You could say it's a repeated answer because I have 2 -3s. But it's important that you understand that the shape is just like our parabola. It is squared, and it happens to go right at the -3. Good job. You did it.